Hello and welcome to Newton's Bench once again. This is lab number 9, and lab number 9 is on Young's modulus. So Young's modulus is a measurement of how much stretch a material will undergo given an amount of strain. So what we have here is Young's modulus is equal to the force for a particular given area. Now that area is a cross-sectional area of, let's say it's a tube or whatever it is. It's the cross-sectional area. If it's a rod or it's a string like we're using, it's going to be pi r squared, right? The force, if I'm hanging something from it, is going to be mass times gravity, right? F equal ma. The change in length over the original length. So force in our case is the amount of mass times 9.8. The large rings are 40 grams. So let's take a look at what we have here. So first what you're going to do is with the lab kit, you're going to measure with just a small ring on, and we're going to call this our original position. It's already stretched out. And you're going to measure how long it is. That's the original length in meters. Okay? This is the zero force level. So as I said, the force in our case would be how much it's going to stretch when I hang one weight on. So I measure that length, and now I have a new length. It's stretched a little bit more. That change of length is that part there. Let me get to that. So the area cross-sectional of this nylon is 0.5 millimeters in diameter. Convert to meters. Area is pi r squared, of course, as I said. The change in length is how much this is stretched. So it's stretched a little bit, given that the amount of weight I put on this. Okay, so I put the amount of weight on this, and it's going to stretch this nylon. Okay, measure that carefully. It's not going to be that much stretch. And as I said, the original length is the length before I put this weight on. Then what we're going to do is we're going to put another weight on. Okay? And when you put that other weight on, you're going to have more stretch, right? And with that more stretch, also I want to mention that you multiply the measurement by 2 because it is a loop. So we're changing the length by a multiplication of 2 as well because it is increased by twice because it is a loop. So after assembling this apparatus, use a small weight on a hook to establish a baseline, measure it carefully, and then add one of the large weights and see how much it stretches. You should be able to calculate the Young's modulus now, given the area pi r squared, 0.5 millimeters for this nylon. Add another weight and measure again, noting how much more length changes and whether you get a different Young's modulus. Your Young's modulus should stay somewhat the same. So that's the experiment that we're doing for Young's modulus, lab number 9.